Hi, once again, this is Nick Graham. Welcome back. Verify the identity. Cosine 2 theta, cosine theta is equal to cosine to the third degree minus cosine theta sine squared theta. And as we can see, we can factor cosine there, cosine theta, and we have cosine squared theta minus sine squared theta. And we know that the expression inside the parentheses is cosine 2 theta. Cosine theta multiplied by cosine 2 theta. Then we're finished. If you want to do the other way around, then we know that cosine 2 theta, cosine theta is equal to cosine squared theta minus sine squared theta multiplied by cosine theta. Then we have cosine cubed theta minus cosine theta sine theta. Sine squared, sorry. It was squared there. Okay. Another. Verify the identity. Then we have cosine to the fourth theta minus sine to the fourth theta. This is what we can see as a square of difference of two squares, sorry. So we have cosine squared theta minus sine squared theta multiplied by cosine squared theta plus sine squared theta. And we know that this is equal to 1. And we know that this one is equal to cosine 2 theta. Okay, some more. Write an equivalent expression for cosine to the fourth theta, x, that does not involve any powers of sine or cosine greater than 1. So we have cosine to the fourth. Then we have cosine squared x multiplied by cosine squared x. Okay, I made some adjustments there so that we have space to solve this. Okay, cosine squared x multiplied by cosine squared x. Or we can use this expression, cosine squared x squared. That's acceptable. Okay, and we know that we have cosine squared here. So we have cosine 2 theta is equal to 2 cosine squared theta minus 1. So if we add both sides of the equation by 1, then we have cosine 2 theta is equal to 2 cosine squared theta. If we divide both sides of the equation by 2, plus 1, sorry. Sorry, I forgot that. Then we have, this will become 1. So if we have our cosine squared, theta is equal to cosine 2 theta plus 1 divided by 2 squared. Why I use this equation or this formula? Because I need to have cosine, powers of cosine not greater than 1. Right now I have 4 powers of cosine. Now I have only 2, as you can see here. I have 2 here. So I need to remove that also. Okay, and if we expand this, we have 1/4 now. As you can see here, this one, it will become 1/4. And we have cosine squared 2 theta plus 2 cosine 2 theta plus 1. As you can see, I don't have any exponent greater than 1 for this expression, for these two expressions. But this one is I still have for this expression. So I can use one more time. My theta now is 2 theta. So it will become like this. We have 1/4 multiplied by cosine squared 2, this one now will become cosine 2 times 2 theta. I hope you can see that, because our theta, we have now cosine squared 2 theta is equal to cosine 2 theta plus 1, and this is our theta now. This is our theta. So we need to substitute the theta. So cosine 2, and our theta is the whole there inside the parentheses, 2 theta plus 1. And then we have plus 1 there divided by 2. We still have divided by 2. Sorry, I forgot. Okay, plus 2 cosine 2 theta plus 1. So if we're going to simplify now, we have cosine 4 theta divided by 8 plus 1/8, because 1/4 times 1/2, we still have 1/2 here, and that one, plus 2/4, that is 1/2. I can put it here. Cosine 2 theta divided by 4 plus 1/4. So if we expand this by 2, then we have 2/8 plus 3/8. 1/8 will become 3/8. So we have cosine now 4 theta divided by 8 plus 2 1/2. That's 1/2 already. Cosine 2 theta divided by 2 plus 3/8. Okay, I will stay there, and in my next video, a little bit different types of identities that we're going to prove. And I hope you learned something, and have a nice day. Thank you for watching.